All right, I don't know if we're going to get anyone else this week, so I think we'll go ahead and start. So my plan this week was to cover some of the stuff that we covered earlier on, again, because those lectures weren't recorded. So I was going to kind of continue with what we were talking about last week. Last week we talked about reading and writing image files and headers and stuff like that. And my plan this time is maybe to talk a little bit about NumPy objects and TensorFlow and stuff like that. 1 second.
I actually have a question, and I'm going to forget it if I let you start.
Go ahead.
Did we ever remember at one point, maybe about a year ago, I tried to explain that I seem to observe that the order of X, Y, and Z is different in NumPy and EMAN?
I have a vague memory of you saying that.
And I think you said you were thinking of going to change it. I just wanted to bring the point up again.
That I was going to change what?
Well, change it so that they have the same.
How would I do that?
Well, I don't know. I guess you would. The .numpy, what EMAN calls X would be the same as what NumPy calls X.
I know what the mathematical meaning of what you're suggesting is. I don't know how you would go about. You'd have to tell the NumPy object that the data was organized in a different order. And I'm not sure how straightforward that would be to do. I don't remember ever promising to do that.
Okay, I'm not saying. I remember we talked about it at least.
Okay, well, I don't know. Actually, that we can start there. That's actually
I was going to say, because I was going to ask a question, actually, because, yeah, so what are you saying the order of how you look at an array in NumPy is different from an EMData object?
That's what Phil was just saying. I don't know yet whether it's true or not.
Okay.
So let's test it.
Okay, I think we talked about it. I don't quite. And listen, I could have made a mistake, so you know.
Well, let's test it out.
All right.
So import NumPy as np, and I also wanted to talk about TensorFlow too. So we'll import everything there. Phil, could you mute again if you're not going to talk?
Oh yeah.
All right. So let's make a tiny data object. So we'll make I don't know, a 5 by 5 EMData object, 5 by 5 by 1, so just an image, and set it to 0. So now if we let's set 0, 0 to 1.0 and 1, 0 to 2.0. And so now what we're going to talk about is converting EMData objects into NumPy objects and also into TensorFlow objects and vice versa, and the implications of those different things, because there are some. So if we want to get a NumPy object out of that, then there are two sort of shortcuts for doing it. You could say n is equal to a.numpy. That's one syntax, or the exact equivalent, which is 2numpy a. So there's a function form and a method form, but they do exactly the same thing. I usually use it this way, but NumPy, just because I find it more intuitive. But the reason the function form exists is because there's also a from NumPy, which can be used to take NumPy objects and turn them into EMData objects. But we'll get to that in a minute. So now if we look at n, and don't put spurious punctuation marks in, we'll see that Visibly, it looks okay. It looks like we moved along the x-axis. But let's see, n of 0, 1 is 2. Yeah. So it's backwards. That's what Phil was complaining about. And the reason that's backwards is because NumPy is using sort of linear algebra ordering for things, which is kind of the opposite of image processing ordering for things. It's a question of whether it's row major versus column major data, or in a certain sense, it's just sort of the order in which you assign these to row versus column. So yes, you are absolutely correct, Phil, that there is this swap in the order of reversal in the order of indices when you access it using this mechanism. We could probably modify this function so it told the NumPy object which was created that it should that the data was in the opposite ordering. But if we do that, then when you print the array like this, if you just print n on the screen, then of course you'd see it in the the 2 would be down here, right? Which
I don't have a good suggestion. I'm just it gets a little, so it rarely throws me, but when I was working with this byte spectrum and the asymmetric unit, it starts to get kind of gnarly.
I completely understand that it's confusing, but the point is that when you access things in an image processing toolkit like EMAN, or presumably like PIX, I think it probably does it the same way as well, or PIL, sorry, PIL probably does it the same way too, that the ordering is X, Y. And when you do it in NumPy, the ordering is, well, it's treating these as a bunch of row arrays. And so what your first index is accessing this subarray, and then the second index is accessing this element within it.
Can it be modified as easily as interjecting a transpose operation somewhere?
Well, yes, but then that's physically modifying the organization of the data.
Well,
so I mean, yeah, we could say m equals n dot transpose.
Well, I was thinking,
but now m is a different image object, right?
Yeah, I was thinking maybe we could say something like n equals transpose a dot numpy or something like that, or maybe you think of that as the same.
Well, the problem with doing it this way is that it's creating a new object. Like I said, there is some sort of an internal storage thing in NumPy which you can specify whether the data is stored in memory as row major or column major, if memory serves. I'm just saying that if you change that parameter, there's still gonna be an inconsistency somewhere, I think. Well,
okay.
Maybe not. I don't know.
Yeah, and again, it rarely affects me, just in this particular case where the boundary is sort of complicated.
Look, you're absolutely right to complain that it's inconsistent. Just that I'm not sure there is a perfect solution.
Okay.
Let me just see. Is it just array? Yeah, here you go. Specify the memory layout of the array. If the object is not an array, the newly created array will be in C order, row major, unless F is specified, in which case it will be in Fortran order, column major. If the object is in an array the following holds, etc. So when we create the array, we could create it with the opposite ordering, but I'm just trying to think of all the implications of making that change.
Yeah, it's important to think of the implications.
I think if we made that change now, then all of Muyuan's code would break.
I was just about to say that, because I've been working through it, and he uses Yeah, he uses NumPy array a lot.
Well, it's not just him. I mean, there is a bunch of code where NumPy is already used. So I think it's probably a problem that we can't fix.
Yeah, I wasn't
We have
even
to be aware of it.
suggesting a global fix, but just the simplest way for me to go back and forth so that if I'm trying to go back and forth, I don't have to define something as Z in NumPy and then
I cannot think of any way around the fact that the ordering of the indices is backwards without creating utter confusion.
Okay. Well, maybe
I think it's confusing, but if you're aware of it, then
Okay.
hopefully you can do it right.
All right.
Okay, so we've created a NumPy object from our EMData object. The first point I wanted to make is that when you do it this way, you make an EMData object and you create a NumPy object from it, that those share memory. It isn't a copy of the object, it is the object itself. So if I say n of, let's do, I'll do 1, 0 just to be extra confused. Let's do 2, 0 just so it's not extra confusing, and we'll set that to 3.0. And then if we look at A, I think that works, doesn't it? Or is that, no, it doesn't exist, sorry. It's modified already in place, and as you see, we have to reverse the order of the indices to find the element that we were after. So I'm saying modifying the NumPy object immediately causes the EMData object to be modified as well. They share the same memory. The only caveat to that statement is that the EMData object doesn't know that it has to update itself. I think we may have gotten to this last week. I don't remember off the top of my head. I know I said it once before sometime recently. So if you look at the a minimum and a maximum, if you modify the value, oh, I got it right. Oh, I guess it hadn't been computed before. Let's do another one. Let's say n of 3, 0 is equal to 5. And now we can look at 0, 3, and we can see that's 5. And now if we do this, you can see that the statistics haven't changed. And the reason the statistics haven't changed is because there's no way, NumPy doesn't have any mechanism to tell EMAN that it modified the values in the array. So the values have been modified, but EMAN doesn't realize that the values have changed, so it doesn't know that it needs to update its statistics. So there's a method on the EMData object, a.update, which is just sets a flag, which says that the values have changed, and the next time someone asks for minimum, maximum, standard deviation, it has to get recomputed. The reason the first time it worked correctly was because I hadn't computed the statistics before. I hadn't asked for minimum and maximum before, so it hadn't computed them at all. So it computed for the first time after the change had been made. Anyway, so that's something a little gotcha that you have to be aware of. But otherwise, what this means is you can create an EMData object and create a NumPy object from that, and you can simultaneously make change. You can make, well, not simultaneously, but you can make changes to the EMData object or to the NumPy object, and they will both see each other's changes. There are some inherent dangers to being able to do that. If I did something like this, actually, let's do this the simple way. Right. So this is going to make 10 different EMData test images. So this is an EMData function which makes one of those S-shaped test images. So it'll call that function, convert that image to a NumPy object, and that'll get returned in the array here. And then I'll repeat that process 10 times. If I do this, it works fine. And if I look at array, it will initially at least seem to be okay. I'll see all of my test images. But since I have discarded the EMData objects, Python could free those objects up at any moment in time. And when Python decides that it's going to clean up the garbage and get rid of free up that data, then the NumPy array is going to be pointing to an array that no longer exists, and you could actually get a segmentation fault. So if you're going to use this strategy of taking an EMAN object and turning it into a NumPy object, you need to make sure that you keep the EMData a reference to the EMData object around as long as you plan to do anything with the NumPy object. Okay, if that doesn't make sense to anyone, please speak up and complain.
I can't say I can't say I completely follow, but
okay, so when you create an EMData object, if I call test image, so let me get rid of this so I don't crash my kernel. All right, so if I create a test image, okay, that is an EMData object. If I then create a NumPy array from that EMData object, then again, they both point at the same data. So when I did this, EMAN allocated a block of memory to hold the contents of the image. When you call this routine, it creates a NumPy object which points at that data that EMAN allocated for the image. EMAN has no record that NumPy has a copy of that data pointer, right? That NumPy is pointing at that same object. EMAN has no way of keeping track of the data pointed to by the NumPy object. So if you do something which deletes the EMData object, which gets rid of A, so right now A is this EMData object. If I say A is equal to none, now there's no more A. It doesn't point to anything anymore. The data could be, it may not have been immediately freed by Python, but Python could free that memory up anytime it wants to. So now B is pointing at a block of memory which was allocated for the image, but then it was freed up, or could be freed up at any moment in time. And if it's actually freed up and you try to access B, it will crash the program. Did that help?
can we see that? Can we see a crash if you do B of 1 or something? Or
well, no, because well, maybe. If I say B of 0, 0 like that, that will access the memory, and it's not crashing right now because Python is not required to free the memory immediately when you get rid of the object. It just may free the memory.
The other thing
there is a way of triggering Python to do its garbage collection, but I don't recall what it is off the top of my head. So
that's fine. It's just interesting. I can't say I would know how, if I were to code you wrote .numpy, right? You wrote that method, right?
Well, someone associated with EMAN did. I didn't.
Oh, I see. I can't say I would know how to write that.
Okay. There's no reason you should know how to write that.
Oh, well, no, I mean, I don't know logically how you would. I mean, I'm just curious. That's all. That's what I'm saying. I'm curious how.
I mean, that involves getting into the internals of how both the EMAN and NumPy store their floating point data in C++.
Okay, so it's quite sophisticated. Okay,
it is a very technical detail, and
yeah, okay.
When that routine was constructed, it was originally written by actually no, I think it may have been written by Li Wei originally.
I see.
And then it was kind of broken because NumPy changed the way it stored things internally.
I see.
So Tune rewrote that routine, and it was not something that he did in 20 minutes. It was something that took him like a week to kind of
I see.
figure out and make it work right.
It's interesting, yeah.
it's interesting, but it's
No, I'm not interested.
It's a very technical detail.
I'm not interested in learning it. I just was curious.
When
So
are we gonna do? Oh,
anyway,
yes.
the point is that if you wanted to do this, the correct way of doing it would be to do something like that, and then array n is equal to a dot numpy for a in array. So now I would have array, which has all the EMData objects, and I would have aryn, which is all of the NumPy objects, and both of the sets of objects exist in both spaces. But the memory is only taken once because they're sharing the same pointers to the same blocks of memory. So you don't have to worry that like you're wasting memory when you do that. Okay.
Yeah, I think it makes sense. I'm just curious. So when it says EMData at 0x15, that's just that's is that literally the memory like scaffold that it's pointing to or something like that?
That's sort of the equivalent of a pointer to where that block of memory sits. That's just how Python displays arbitrary objects. So this is within Python's own internal memory space. So it's not something that you could really do anything very useful with in most cases.
Okay.
But the reason they show it at all is because you can see that this number is different than this number. So if you ever see the same number appearing, you know it's the same object. Okay, now just to make things a little bit more confusing, let's say I have a NumPy object. We'll call this one M. So let's make a 10 by 10 array of zeros in NumPy. So if we look at M, right, it's just a bunch of zeros. Now I'll convert that to EMData. We'll call that this one B is equal to from NumPy M. Okay, now B is an EMData object, and B of 0, 0 is 0. Everything's 0, so everything I got out is going to be 0. But anyway, so this would seem to be exactly equivalent to what we did up here, except in this case we started with a NumPy object and we converted it to an EMData object. However, that's not quite the case. In this case, when I do it in this order, if I say B of 0, 0 is equal to 1, and I look at M will not be changed. When you convert a NumPy array to an EMData object, it makes a copy. When you convert an EMData object into a NumPy array, it doesn't make a copy and they share memory. Now, while that may be slightly confusing at first glance, it's also very, it's an important capability because it means that you have the power to do it either way. So if you need to have shared objects, you can, and if you need to have individual copies, you can do it that way too. Now, of course, if you have a shared object, you can always make a copy of the shared object. So the other strategy for doing what we were doing up here before, right, so I was saying that if we did that, isn't safe because I'm throwing away test image. I make test image, I turn it into a NumPy object, and then test image is getting thrown away. So this would not be a safe way of doing it. But if I said copy like that, that would be completely safe because that makes an EMData object, turns it into a NumPy object, and then it makes a copy of the NumPy object, and then it throws away the NumPy object and throws away the EMData object, and the only thing it keeps is the copy. So this would be another safe way of making a bunch of NumPy objects from a bunch of EMData objects. You put a copy, and you'll actually see places where Muyuan does that because he's afraid of the whole memory freeing thing, that he may not be keeping track of things right or something like that. So he does that sometimes as a safety measure. Anyway, so you have two strategies. You have two NumPy, which will create a NumPy object from an EMData object. That does not make a copy. It points to the same memory. And you have from NumPy, which will make an EMData object out of a NumPy object. And that does make a copy of the data. And it does not ever point at the same memory. Okay. So that's NumPy. The other thing that you might want to do is create TensorFlow objects. So creating TensorFlow tensors, TensorFlow has its own set of constraints around objects, and that's mostly because of the fact that TensorFlow has to work with hardware like GPUs to optimize its performance. So if I have a NumPy array, so let me go back to a simple case here again. So I'm gonna make A is equal to EMData. Oh, sorry, test image. We'll do test image. Test image.
Hello guys, my name is Anna and I'm Ukrainian, and I have decided I will log daily from my
someone that isn't muted.
Sorry, there's something came on. Sorry about that.
All right. So if we create an EMData a test image again, and we say b equals a dot NumPy. Oops. Now we have our NumPy array, and if we want to make a TensorFlow tensor out of that, there's a couple different ways we could handle it. The typical thing would be to say t is equal to TensorFlow dot constant b. Okay, I can't do that directly from the EMData object. I couldn't say constant a. There's no automatic conversion of EMData objects into TensorFlow directly. You have to create a NumPy object, and then you can create the TensorFlow object from the NumPy object. That may be something that we rectify at some point in the future, but it's not really a very big deal. So anyway, now you'll notice, since this is the first time I use TensorFlow, we see the initialization strings from TensorFlow itself. If we do it again, that stuff wouldn't show up. And you'll notice that actually the TensorFlow is now finally beginning to support the M1 chips. So the hardware acceleration built into the Apple custom hardware now. Anyway, so here we've created T, which is now a TensorFlow tensor, which will look very much like the NumPy array, right? So data type is float 32, and then there's the array, and it looks pretty much just like a NumPy array. But it's different in a number of ways. For example, if I say t of 0, 0 is equal to 1, it'll yell at me. TensorFlow.python.framework.ops.eagerTensor does not support item assignment. And that's because the tensor that I created here was a constant tensor. So I was telling TensorFlow that once after I created this tensor object, the values were never going to change. Why is that important? That's important because TensorFlow is going to then want to copy that data into the memory on the GPU. Okay, so when you create a TensorFlow array from a NumPy array, the memory sharing behavior is undefined. Okay, what that means is that my B may be sharing data with A, or it may not be sharing data with A. You cannot rely on either behavior. In most cases, it's going to be making a copy because it's going to be copying the data into the GPU memory, and then the tensor is basically living in the GPU memory. And the reason it's important to declare that the array is constant for TensorFlow purposes is if TensorFlow knows it's constant, then it knows it can put it in the GPU memory, and it's never going to change, and it can just leave it there, and it's never going to have to go through the expensive process of copying it to the memory again. But if it's something that's going to get updated all of the time, then if you try to manipulate the data on the CPU, it's going to have to copy the data back off the GPU onto the CPU again every time because it might have changed. So these are just complexities of TensorFlow itself. when you're dealing with TensorFlow and NumPy and EMAN2, it's basically there's a connection from EMAN2 to NumPy, and there's a connection between TensorFlow and NumPy. NumPy is the intermediary for all of these operations. So as long as you as long as you follow all the rules for TensorFlow interacting with NumPy, and you follow all the rules for EMAN interacting with NumPy, everything should be safe. You don't have to worry about learning another set of rules for EMAN interacting with TensorFlow. It's always indirect through NumPy as an intermediary. All right, any questions about any of that? I'll take that as a no. So this also means that if you're trying to learn TensorFlow, there is stuff that you have to learn. That this choice of making constants versus dynamic variables in TensorFlow is not an arbitrary choice. It's something you have to very carefully consider because it may have very profound performance impact on anything that you do from that point on.
Would be, I mean, if time allows, I would be curious to see a piece of code where you did different things or defined things differently or something. I don't know. I mean, if you happen to think of something right there.
Fine. I don't have any good examples in
mind. Okay. Yeah. Okay. Just
if we start getting into TensorFlow and processing cryo-EM data with TensorFlow, which is something we could do, that's probably a multi-session kind of thing we'd have to start talking about. It's not something we just fill.
Is there anything different, since we're on the subject? Is there sort of, like, if you take some simple course on TensorFlow, is there anything beyond that you need to understand to do, the kind of thing we're doing?
You're saying if you took a simple course in TensorFlow, would you learn everything you needed to know to do the sorts of things that we're doing deep learning in EMAN2?
Yeah, I guess that's about the right question. Yeah.
Okay. Most of the stuff that we're doing in EMAN2 with TensorFlow right now is being done via Keras or Keras, or whatever you want to pronounce, however you want to pronounce it, which is a structured set of deep learning layers, where a lot of the connection between the deep learning logic and the lower level tensors themselves is sort of all handled for you. You just say, I want this layer, and I want this layer, and I want this layer, and it handles all of the tensor math for you, basically. In the earlier days of EMAN, a lot of this infrastructure didn't really exist yet. We weren't using TensorFlow at the beginning. We were using a different deep learning toolkit at the time. So a lot of this stuff has sort of evolved. But I think right now, all of the deep learning code in EMAN2 is using capabilities available in Keras, not sort of low-level TensorFlow stuff. There is a little bit maybe of low-level TensorFlow stuff, just in the sense of maybe calling a Fourier transform or something like that explicitly, but nothing that would be conceptually difficult to understand, right? We're not making up our own ways of doing neural networks or something like that. So the basic answer to your question is yes. If you learn how to build deep learning models using Keras and TensorFlow, you should be able to then take that to an understanding of most, well, pretty much anything that we're doing with TensorFlow and EMAN2.
Okay, great.
All right, so we've sort of covered this issue of getting EMData objects into into NumPy and TensorFlow, and how all these things interact. A little bit that you have to be careful about memory management. I wanted to cover one more time sort of the visualization question. How would you go about doing visualization of any of these objects from the Jupyter Lab environment? If you want to write full applications, to do graphical display and stuff like that, then EMAN has this nice set of Qt widgets, and we spent a lot of time earlier on writing our own Qt widgets and learning how that infrastructure worked. But if you want to do it from a Jupyter Lab notebook session, then there are different strategies you can use. If you're creating a NumPy object, then obviously you can use any sort of visualization scheme that's available for NumPy to display things. But if you do it that way, you will lose a lot of the capabilities you might get from EMAN style visualization. So if we have one of these test images, so I've got my A EMData test image, and I've got my B NumPy array version of the test image. So I could say, from PyLab import star, and I could say something like plot B. And there we go. We've got a 2D plot of all of the individual rows moving up the, the widget, right? You could do.
I actually have a question about, because I was actually doing this yesterday, and I was confused. At first, I didn't realize the plot came after all of the. Do you know why it is printing all the MATLAB lines too?
I do. I mean, this is printing the text return, and then this is just sort of this is an interpretation of all that stuff in a sense.
Okay. Yeah. Okay. Yeah, because it threw me off for a second until I saw the plot at the bottom.
So I mean, I'm using this shortcut PyLab thing.
Right.
If you really want to do it properly, you'd import from matplotlib and then do it with kind of the lower level commands. I'll also point out that EMAN has its own plot internally, which if you haven't done this from PyLab import star and overwritten EMAN's plot, you might be getting that plot instead. The other thing, then I mean, you could do other things too, like imshow, I think, imshow B, right? And you could, show the image. So there's the representation of the image, but of course this is done using a color map representation. So it's not the standard EMAN kind of grayscale implementation.
I think you just do gray before gray parentheses.
Yes, yeah. you can. But what if you want to adjust the brightness and contrast? Well, then you have to come up with additional modifiers to the command. There's no sliders you can drag or anything like that. So yes, absolutely. If you like displaying things using matplotlib, you can do it this way. You can also make use of other toolkits like Bokeh, which is another nice more interactive toolkit for doing this sort of thing. So if you say, let's see, I don't remember my Bokeh very well. I think I may have done it earlier. Yeah, there we go. Yeah. Then you say output notebook. And then you could do something like plot B of 0, maybe, or maybe B. Let's pick something from the middle. Oh, no, that's getting matplotlib still.
Well, that's cool. I got to get that on my toolbar.
That's it. That's it. We say P dot P equals figure. And then we say P dot plot B of 64. Oh, there's no attribute plot. What is it? It's not plot, something else. Maybe I can do filling on it. Plot. No. No. All right, let's look it up. That's image. So these are all sorts of things you can do with Bokeh. Source code for this, maybe. Yeah, that's messy. I want a simple example. There we go. Scatter. That's what I wanted. There we go. B of 64. And for some reason, it doesn't always load right the first time. It may be upset that I'm trying to use PyLab at the same time. Let me restart the kernel. And then I'll re-import EMAN. And then we'll just do, let's see, A is test image, B is NumPy array. Do this, make a figure, E.scatter. Huh. Maybe you have to do a show too. No? I've done this before. You can see I don't do it very often. Oh, show P. There we go. You have to get your syntax right. And we're not seeing anything.
Where is show coming from? Oh, show is coming from Bokeh. I see.
Show is coming from Bokeh.
I see.
I'm not being very successful in my Bokeh example here.
I never heard of Bokeh. What's its attraction? It just has a lot more stuff
It's
in it?
interactive.
Oh, I see.
So here's an example of Bokeh.
Oh, nice.
Right?
Oh, that's great.
You can zoom in.
Oh, terrific.
And reset. So if you're just doing plotting and stuff like that, it provides some nice interactive interfaces.
Nice.
So it's definitely superior to Matplotlib for a lot of things.
What's output notebook?
But that tells it that you're outputting in a Jupyter Labs session, not to a static web page or something. So Bokeh is something that was written in JavaScript. And then it's an interface to Python to the JavaScript code, which is then running in your web browser.
I see.
So unlike Matplotlib, which was originally designed to be sort of a press system to produce images and that sort of thing, which was then modified so it could have an interactive interface via things like Qt. Bokeh is a JavaScript system which is designed to run in a web browser, which they then retrofitted things like saving as PDF and stuff on it. So like here, there's a save button, and I could save it as, well, in this case, it just gives me a PNG, but you could control which widgets it shows you here and stuff like that.
Wow.
If you hit the gallery here, you can see that they support a lot of different things. Right?
Yeah, 3D stuff in Matplotlib is clunky. So
yeah, it's the 3D stuff in Bokeh is kind of is pretty limited. Bokeh is mostly for 2D stuff.
Oh, okay.
But it has fairly complicated 2D stuff, right? So like, this can give you some interactive multiple graphs attached to each other and that sort of thing. So there are some nice things you can do in Bokeh.
Can you rescale the axes interactively?
That's what the zoom.
Can you rescale them one direction over the other?
If you zoom asymmetrically, then sure.
Oh, I see. Oh, I see, like that. Oh, I see. Great.
Oh, that's something else, right? That's a selection. Anyway, they have all sorts of tools.
Oh, okay.
So Bokeh is nice. So if you want to use Bokeh for your visualization, the other thing, which again I showed earlier in an earlier session that wasn't recorded, is this new EMAN semi-interactive approach where you can run E2. Oops, sorry, wrong window. You can run E2 display.py -- server, and it gives you a mechanism where you can get these EMData objects into standard EMAN widgets for interactive use. So now if I say, all right, let me skip this stuff. I'm going to go back to A. Right, so A is my EMData object. now I can say E3, oops, there we go, E3 display, A, test, like that. Oh, sorry, I need to say that it's image.
Can you explain the syntax of display again?
I will. I'll get to that in
Okay.
a second. So I'm going to do this. If I do this, oh, sorry, I'm at the wrong screen resolution on my Mac again, so it's not copying images properly again. One sec, let me fix that. So this is a Mac specific thing. It's a problem between Qt and the Mac, that if you're in a super resolution display mode, Qt doesn't always get things right.
Can I add a note just for if anybody that's a beginner that's watching this of I feel like there's one sort of thing you gloss over when you go to the terminal. You got to Control Z and then BG and then Control
Well,
Z.
you don't have to. You can just do it in another terminal window.
Oh, really? Okay, we'll see.
I mean, you can run the E2 display. You can run from any window any terminal window you want.
Oh, I thought it had to be the notebook.
No. There's no connection between where you launch. You can run this line anywhere on the machine that you like.
Okay, well that's helpful. That's good to know.
Yeah. There we go. So yeah. So the difference you can see here is that before I was running in my screen resolution. Sorry, I lost it again. My screen resolution had been set to 1920 by 1080. This is a 4K display that I'm looking at right now. So when you display 1920 by 1080 on a Mac on a 4K display, it gives you effectively 1920 by 1080 on the screen, but it actually makes use of the full 4K when it's rendering stuff on the display. So it's like the Retina style displays when you do that. If you say 1920 by 1080 low resolution, then it actually sets the monitor to 1920 by 1080 mode. And things will look a little more pixelated, but then a pixel is a pixel. There's no extra interpolation step. That's a Mac specific thing. Okay, so back to what I was doing here. So I said E3 display, I had an EMData object. I said image, test, and you can see it appeared here. Also, a line appeared in this empty window that popped up when I said E2 display server, and this widget appeared when I did this. If I make another test image, one of a different type. Now, one thing you may notice here is that my web browser has gotten a little sluggish. That's actually due to Bokeh. I think there's some JavaScript running in Bokeh in the background here now, which is kind of making my Jupyter session a little bit sluggish. But anyway, I'm just saying it's maybe one of the downsides of Bokeh. So let me do this again. Another E3 display. Now I'm going to display B image, and I'm going to say test2 here. Okay. And now I've got a different test image here, and you can see that another line appeared up here. So this is test, and this is test2, and somewhere on my screen, there it is, another window opened up, which contains the actual image. So the trick is that this isn't interactive. This is just a more or less a screenshot of what came out of the image object. At the moment, we don't have any way of doing interactive sliders or anything like that inside the Jupyter Labs session using these EMAN2 widgets. But what this accomplishes is it sends the image to this image server, so you actually get the widgets over here, and you get the full control panel and stuff if you play with it here. Oh, it looks like I've got the slider problem again. I thought I'd fixed that. All right, I'm gonna have to take a look at that. Somehow that change must have gotten undone. Anyway, so you get the full the access to the full EMAN style image display widgets where you can adjust the brightness and the contrast and that sort of thing. And if you want to update the image, all you have to do is send a new image to it. So if I say a.mult, actually I'll do it down here just for convenience. A.mult b oh, actually that, oh yeah, that's right. That'll modify A in place. And then I can do another display here. And if I give it the same name here, it's going to sort of overwrite the image over here in the widget. So this, and now you can see it's been cut off at the edges. So, oops. You can sort of see the sharp edge in the top here, right? So that was because I multiplied it by that. So there's sort of that mask that's been applied to the image. So anything that I do over here will show up over here, but it won't show up until the next time you update E3 display. You basically have to get it to re-render itself for it to show up in the preview here. But if you want to do some interactive display on 3D objects or 2D plots, this supports many of the different widgets in EMAN2. So if you say help E3 display, oh, there we go. You can see the parameters to this are the data object you want to display itself, then the type of data, how you want to render it. Sometimes you might want to display, say, a 3D volume as a 2D image or something like that. So if you want to do that kind of thing, then you would pass in the data, you would pass in a volume here, and then for the data type, you would say image, and then it would pass the 3D volume data into a 2D image object for display purposes. So you pass the data, the type of rendering that you want to do, the type of widget you want. So the types of widgets that are available are the standard 2D single image widget, the image matrix, which is the tiled image display in EMAN2, the volume rendering panel, which lets you do isosurfaces and volume rendering and slices and that sort of thing, 2D plots, 3D plots, and histograms. So right now, those are the 6 widget types that we support. You can also optionally give the widget a name. So the name that you see here is image_test. It's image because the type of widget is image, and then it's test because I gave it the name test here. If I say XYZ here and execute it, then it's going to have image XYZ over here, and that will open a new window, a new widget window on the screen. So I can send my image data to whichever one of these widgets I want, depending on what I pass in here. So if I want to send B now to this window, I can say B, and I can pass it to test. And now you can see B, now this widget now contains test, and you can see it still has the same zoom and contrast and everything like that that it had before. Then the last thing here, the next thing here that you can pass is the data set name. So if you're doing something like a 2D plot, so say you're plotting several different line plots, you computed, say, the Fourier shell correlation 3 different ways, and you want to plot them in the same window, then you would use the same V name for all 3 plots, but you would give each plot a different D name, and then all 3 would be displayed at the same time. It wouldn't replace the data. When you do a 2D single image display, every time you pass it an image object, it replaces the previous image object. But the plot 2D, plot 3D, histogram, and volume widgets all support displaying multiple data sets at the same time. Does that all make sufficient sense?
So that's why you're able to have, so that's the D name in this case is the second test.
Here, let's do it. Let me do this again. I'm going to say A.
I mean, yeah. Ultimately, I was just wondering, what's the point of having that last test in the E3 display?
I understand. So this did nothing for the image display.
That's what I thought.
It was kind of pointless. Well, it may have. Yeah. It's pretty much useless in that particular use case. So let me make a test image 3D. And we'll make another test image 3D type 1. And then we'll say E3 display A volume test again, and we'll give this one the name A, and E3 display B, volume test. So I want it to go in the same widget, but we'll give the data set the name B, and we'll do that. And there's our window. Here's the actual window. The reason this is so big and it's got all this white space out there is the white space is transparent, and so it's getting mapped to white over here. But you can see here are the two objects. And if I open the control panel here, you can see one is an isosurface layer, one is A and one is B, and there's an isosurface for each one. And I can adjust the isosurface threshold. You can see the lines get thicker or thinner there. And I can adjust this isosurface threshold, and you can see that object changes size, or I could turn off B or on B, etc. And if I then call this again, it will update with the orientation and everything that I had set over here. So anyway, this can be another convenient way of rendering your data. All of the NumPy methods for rendering your data are great, and you can use those. But if you want to do something like make a 3D visualization in some particular orientation, and then you want to change the data that's going to it a bunch of different ways, then this mechanism provides a nice, easy way of doing that. I should also point out, if you accidentally do something like, say, close this down, it's not going to cause this to crash immediately. If I try and run this again, it's going to complain that it doesn't have a server to talk to anymore. But if I just go back here, and I can go to another terminal window, like I said, if I say conda activate E3, E2 display server. So if I start another server process running, obviously it won't have the data from before, but if I send it new data, it'll be fine. It'll just start from scratch. So you don't have to worry about closing this accidentally killing the session or something. You'll lose the orientations and stuff that you might have said, but other than that, it'll be fine. Okay, well, we've been going for about an hour now. Does anyone have any questions about this display stuff in Jupyter?
I have a silly question. So I noticed that Bokeh immediately is packaged with Google Colab, but I didn't see quickly how to get it into the Jupyter notebook from E2.py or E3.py.
Huh? What do you mean?
If I do import Bokeh within the Jupyter notebook created by E2.py, it doesn't seem to recognize it.
You must not have installed Bokeh in your Conda environment.
Okay. So I go back to Conda and install.
You have to do any of these packages you want to use.
Okay.
From
Okay, no problem.
E3 has to be in your Anaconda environment for EMAN2.
Okay.
Yeah.
Okay, good.
Okay. Any other questions?
Just a comment that I thought the TensorFlow idea of doing a few sessions on that sounds like a good one. But
The TensorFlow idea of doing what?
You had said, if we were going to get into more of the details about using TensorFlow.
Oh, you're suggesting that in a future session we should talk more about TensorFlow.
I would be curious for that.
No, I think that is something that we'll probably inevitably get into. I just thought I wanted to get some recordings in place for some of this earlier stuff first.
Yeah, makes sense.
I think next time I'll probably do a little talking about image processing operations that you can do within EMAN2 objects and that sort of thing a little bit more, and then we can move on to other topics. I mean, that's sort of the last of kind of the basic introductory topics that I haven't really covered yet.
Since I'm often using these tools to check ideas and code, is it easy to label like the axes, like X, Y, and Z on the output?
You mean this?
Yeah.
This widget does have annotation support, including text, but there is no easy X, Y, Z. I mean, there is no axes. The axes that you're seeing here were the test image 3D type 0. right? These aren't axes that are being displayed as axes in the display. If you want to plot things, if you're plotting numerical data, then you wouldn't be using this. You'd be using the plot 3D object.
Oh, I see. Yeah, that's true.
So the, when we did the help,
Right.
yes, I
Right.
lost
No,
it.
I remember. I
Yeah,
remember.
we put plot 3D here, and then that's using EMAN's 3D plotting widget, which does have axis labels and stuff like that.
Oh, okay. Very good. Yeah.
And that can be interactively rotated, but again, it can only be interactively rotated, in the window. It can't be interactively rotated in the Jupyter session. I'd like to add some interactive features, over here, but it's not a completely trivial thing to accomplish. So
yeah,
in the future maybe.
Do you think you do it with JavaScript like Bokeh, or do you think, I don't know? It doesn't.
The easiest way to accomplish adding some interactivity to these things would be to use the Jupyter widgets. So there are some slider and other sorts of widgets that are available within Jupyter Lab itself, which can then tie back to Python code. So we would implement some Python code supporting that kind of behavior. I can pull that concept up really quick in case it's something that's useful to people, because it is a useful thing to be able to do within your Jupyter Lab sessions. Let me see. I think here. No, sorry, this is from a programming class I teach.
I'm having flashbacks.
Huh?
I'm having flashbacks.
Yeah, sorry. In Bokeh? No. Where was that? I'm just trying to remember what lecture I talked about that stuff in. Image processing, writing programs, program flow. I'm completely blanking out on where I talk about the slider stuff. Oh, it must be the GUI. Yeah, it's the GUI module. That's right. Yep. Here it is. IPy widgets. Let's see. Where's my good example? Well, that'll work. Yeah, this is good. So if you do this, so we import IPy widgets, and then there's this interact method, and all you have to do is call interact with a bunch of stuff that you want, variables that you want to be modified, and then that'll immediately produce sliders and stuff like that. And you can see, so these are the variables that are being modified, and then this is the name of a function which takes those variables as arguments. So every time I grab the slider here, for example, it calls f with the new values. So this line that you're seeing right here is the output of f, which is getting called every time I do stuff.
Can you use the outputs in a plot?
You can do anything you want with the values inside f.
Oh, okay, good.
So if you had f regenerating a plot, that would be fine. But if you did it with something like matplotlib, that would mean that it would be regenerating the plot, redrawing a 2D figure, and then sort of sending it back to Jupyter Lab again. So I suspect it would kind of flicker and not look really pretty. Whereas Bokeh is all being done internally via JavaScript, so it looks really nice and smooth.
Oh, I see.
So basically, this is a really easy mechanism for doing interactions, but it may not be a very sort of professional implementation. But if all you need is to have a couple sliders because you're playing with some variables and you don't care if it looks good or not, this is a really easy way of getting access to that kind of functionality from within Jupyter.
That's good to know. Oh.
Yeah.
But you wouldn't use
sorry.
it. You wouldn't use it in a plot, right? You're saying so much.
Could use it in a plot. I have another example of that. Here, let's use this.
Looks like you've already added quite a bit to the class since even just 2 years ago. That's cool.
Maybe.
I
So
don't
there you
think-
go. Here's a plot. It's interactively doing a Fourier transform, and you're adjusting the values of where the two delta functions go in.
Oh, nice.
Actually, it's sort of the other way around, right? You're computing the sine functions, and then this is the Fourier transform of them, and you're seeing that they have some width. They're not actually delta functions, but anyway.
It'd be. I have an immediate use for that.
Okay, well, but you can see how it sort of flickers as I drag. It's
Oh,
but
that's
still,
okay.
it's it's okay.
I want to has some control parameters to control the shape of these triangles I've been drawing. And
Yeah, right. So if what you're after is just a really quick hacked up kind of GUI with sliders or something, this gives you a really easy way of doing it.
Yeah, this is perfect.
Okay. All right. Did someone else have a question? I thought I heard a voice. I didn't see a face.
Yeah, I was just going to ask if there's, basically I'm picking up that there's no way to embed any sort of Qt widget into the Jupyter notebook.
No. So Qt6 has a new thing now called QML, which is designed to be used for sort of richer interfaces if you want to implement something on a cell phone or something in a web browser, something like that. But it's sort of a complete replacement for their whole previous generation, the widget scheme that they've been using for 20 years. This QML thing is a replacement for it, and it's not as flexible in a lot of ways and stuff, but apparently it's easier to implement in certain ways and stuff. So I have some hopes that maybe if we transition to Qt6, that we might be able to make use of some of that to add some interactivity in the context of Jupyter. But having said that, I don't know if QML talks to Jupyter well. I'm not saying it doesn't. I'm just saying I haven't researched the topic, so I don't know. Okay, well, with that, I guess we'll stop for the day, and then next week we'll maybe talk about some actual image processing with some of these objects, not just looking at them and stuff.